Hello, I'm going to introduce the idea of a proxy class. It's an intermediate class to protect what we're actually doing. What does that mean? Well, we have our goodies, our main class, where we have our functions. In this case, I generically said foo, boo, and zoo. We have our data. We want to protect this. Our data will be private, of course. Our functions will have to be public. So all access normally will go through a client program, which will call foo and boo, and it'll have its own data. The problem with this would be that if I have to change foo significantly, the client may have to change. And clients could be all around the world. There could be many, many clients. What I'd like to do is avoid putting all my eggs in one basket. What I'd like to do is, this is ultimately our goal, is to take our goodies and create a middleman, a proxy. And our client will then call the proxy, in this case A, B, and C. And these functions will then indirectly, through a pointer, call our goodies to have access to foo and boo and zoo. If anything goes wrong with our goodies and we have to change foo significantly, what we do is we change our proxy, and the clients are left alone. So what we've done is we've isolated ourselves with this tiering. So in terms of engineering, we're going to look at separating our definition of our objects from their implementation. We're going to look at creating this proxy, this interface, and of course protect our data. Here's a very contrived but simple wrapper or class. My goodies, I don't know what it is, but I don't want people to see the name of this variable, my worker. I really don't want them to see getX or setX, because I could change my mind about this. There are many things I could change my mind about, including how I write the code. Here I set the value default to 0 if none is given, pass the value into mWorker, and it's set. Here I just return the value of worker, and here I take the value, which could be 0 if none is given, and set my worker to that value. And I'm putting all my eggs in one basket. I have this one thing where I define my object and I implement it. Notice I'm defining it and implementing it here. I'm telling you what the thing looks like. There's my definition and how it works. Here's my definition in terms of my fingerprint or prototype, what a getX looks like. Here's what getX does. Here's my setX, and here's how it works. So, major point here is we've taken this definition and implementation and partitioned it. Here is the fingerprint or the definition. I'm not telling you how anything works. I'm just giving you the prototype for everything in it. And its access method, that is this access modifier, that is mWorker is an integer, but the access to it is private. So that means only things that are part of the class called myGoodies or friends of myGoodies have access to the worker. Here is the implementation. Notice the implementation has to include the prototypes right above here by saying myGoodies.h, that's the name of this file. And I say, take the function myGoodies and put it inside myGoodies. And I'm telling you exactly how it works, or I'm telling the compiler how it works. Here I'm saying getX, take getX, and place it inside myGoodies. This is the scope resolution operator, the colon. There's a closer look of the prototype definition. I'm using this technique that says for the preprocessor, if not defined, myGoodies_h. That is, if the system, the preprocessor, has never encountered the syntactic entity. By syntactic entity, I just mean it's a bunch of letters thrown together. It doesn't have to be an integer or a number or a double. It's just this group of, or string of letters exists by itself. If you haven't seen it before, I come into this block block. Yes, if you look at line 17, it says # end if. This is the block. If you've never seen this entity before, come in here and define the entity. So now I've seen it, which means I will never do this block of code again. Here I use the directive to say just work through this once. It's sort of a shortcut to using all the other stuff. So here's the implementation again. Here I have to provide the prototype so that the compiler sees that I'm not breaking any rules. That's what prototypes are for. Next, the client. Client says, okay, it has to know the prototype as well. Ouch. So now the client is seeing inside my goodies. And what I simply do here is I create a reference, a pointer to my goodies. And I say create a new instance of my goodies, give it the number 5. New does two things. It will create a block of memory that will hold my goodies, and it will call the constructor. Then over here I say A has an offset. This is a memory location A. It says whatever it's pointing to, go to the offset known as set X and give it the number 45, and that's a function, otherwise known as a method, and it will execute. When I come back on line 14, again, go to A, move over with a function called getXes. It returns a value, I print it up, and then I do some cleanup. It's kind of optional here, but I just ask the system for memory. I'm giving back what I've taken. Now, suppose I took this client right here, my goodies. This is the thing I'm going to make money with. That is, I'm going to license this to my customers. They love this function, the goodies. They say, oh yes, we want a copy of your goodies. So I say, all right, I will license it to you. So what will I give them? I will give them the header file so that the compiler knows how to go into what? Into this library. .a. Notice it's not .exe. You cannot execute this. This is an ASCII format of the library. And you look, you see goodies set X and goodies get X. And if this is a release version, otherwise you'd actually see M worker in here. Variable names would be in here. So I sell this license to a client, and now they can use my goodies. Normally a client never should access private methods or datum. Now, in the client's header, I can scrub out or remove the place where it says private M worker. Why? Let's go back up here. The client is not allowed to and should not access this, so why should I even tell them about it? Whoops, went a little too far. So I scrubbed the private methods, and if there were methods, they're removed. So the client now has this thing, and they have my library. Here's the client's program, their main program. They say, great, let's use this brand new library of goodies. We love it. And notice it looks exactly the same. I can set X, I can get X. Oh, I'm so happy with this library. However, let's take a look at the internals. This is a point of view of what's going on. When I create a class called foo, and I say have integers A, B, and C, you can picture it as a table. The first integer A has a beginning, a position. This is my spell checker complaining. It says, where does foo begin in memory? Move over 0 bytes. That's where A is. So A isn't really a name. It's a position in the table. B, go to where foo is, the beginning of the table, and move over past the first integer. So if we go past A, you get B. C is 2 integers over from A. But where is C? Well, wherever this foo exists, wherever it's been created, that's the location foo, move over 2 integers, and that's where C is. So these aren't really names. They're really going to be a base address plus some displacement or offset. When you program and use a keyword like private, it limits the scope of variables for compilation. That's for the compiler to compile things correctly, not for mistakes downstream. That is, once you have the library, the client doesn't care what the name is. It just accesses things by type. That is, everything's just an offset, the distance from the beginning of the class. A library cannot stop you from accessing anything inside it. They're hackable. So here's what you've given your client. You gave him a library with all his stuff in it, your goodies. This back here is actually the hex code for this library that I created. I just did a snippet. And what I did was I corrupted the header file, or the prototype definition. I put integer a, which is really the worker. And I'm going to say hacked. What I mean by hacked, I mean people used to do this in the 80s all the time. If you could find a shortcut to get into something, you just did it. So instead of getting and setting X now, I can just use A. So I bypassed this. And that's bad programming. Going back, I've done this. The public variable is now, this is now made available to the compiler. The compiler has no idea what's going on. It says, someplace, any place where you create a my goodies, if you move over 0 bytes, that's where A is. So it will generate that code to access that first variable. Even though I called it A, it's really M worker. Doesn't matter. It's just a name. The library does not and cannot prohibit access. Even though you know this was supposed to be, that is, the intent was this was M worker and it was private. So here we are. I ran the program with this, and notice I said foo directly accesses A. I directly went to A, and voila, it changed it. Notice that. This is private, yet I got in there. Yes, I got in after the fact. And of course, I use foo just to relate the idea that this is a table, even though it is a class. I want to avoid direct access. I want to make them earn it. If they're going to hack in there, let them work for it. The proxy class, that middleman, a wrapper, an interface can be used. Again, I have my goodies. I want to set up a middleman so that my client cannot, I'm not going to make it easy for the client to just scooch right over there. You can still do it, of course. So I want all requests to go through the proxy interface. So here it is. The middleman, the interface for it says, here's my goodies. Notice I say class, my goodies, a forward declaration. This thing does not know about my goodies. It only knows it's coming. And it's a pointer to, I use P for pointer, pointer to my goodies. Now the implementation for the proxy says, all right, it's got to know both, the implementation. The implementation says, you give me some value. I'm going to create, for my pointer to my goodies, a brand new goodies. Give it that value, default 0. I'm going to be able to, you give me a value, I'll set the value for my goodies. I'll get the value for my goodies. And there's even a destructor here that says when I no longer need the proxy, I will, this is sort of cheap security, I'll set the value to 0 and then I'll give it back to the system. So what does the client actually see? Here's your library, and you can notice it now includes C interface, and my goodies are here. But instead of me going directly to this part of the code, I will go up to this part of the code and then move down. Of course, you can still bypass this and go straight in here, but again, we're trying to make people earn stuff, not just give it to them. So the client code will use this interface And notice I even sanitize this a little bit by getting rid of the fact that it's got a pointer in there to the client. I even changed the name. It's not getX or setX. It's getValue, setValue. So here I'm used to, you might recognize it from code blocks. I set up a main program. Main program says I want to use my proxy. I create my interface. I give it a number. I can set and get values and clean things up. Here's my interface. There's my library. There's only the partial library shown. This is just symbolic. It's not really everything. Now, in order to get this to work, I need somehow to get this program that is my client code to link to this library so that when I say set X and set value and get value, I actually come over here to the right code. So I need to alert the linker to the whereabouts. And this is the same for other IDEs, Visual Studio, etc. Using the code blocks idea, I went to my project build option, looked, I wanted release, went to linker settings, add a file, look for the directory. Here it is. I found the directory on my machine where my library was compiled, clicked OK, and I'm done. Major point here is a proxy will insulate you from changes. Major point here is a proxy's methods are an interface. That is, it's a public API set to control some implementation or some framework. That is, instead of talking to something directly, you use a middleman. This way, it allows you to change how you build things later on. The end.